In this lesson, we'll concentrate on the date column of our data frame. Let's check its content by executing df-reason-mod date in brackets. Each of its values shows a date in the following way: day of the month, month, year. At the same time, forward slashes are not used for writing integers or floats, for example. So, does this column contain strings or values of another kind? Let's use the type function to find the answer. Type df-reason-mod indicates the entire column is a Python series object, and that's fine. Every column in a data frame is in the form of a series. But this doesn't tell us much about the data type of each of its values. And don't forget, in one column or in one series, we can have values of a single data type only. So, let's check the type of the first value of this series by running the same cell after adding a 0 within brackets just before closing the parentheses. str stands for string. And this makes sense, doesn't it? We have just received a dataset where the data values have been stored as text. What we will do now is introduce a data type called timestamp. This is a classical data type found in many programming languages out there, used for values representing dates and time. To convert all values from the date column into timestamp values, we can use the pandas toDateTime method with an argument the date column itself. And here's something very important. When you are doing this conversion, you must always specify the proper format of the date values you will be working on. Remember, if we don't do that, the subsequent conversion of the dates into timestamp will probably contain errors that we want to avoid. To elaborate on the subject, let's first execute this cell without designating the proper format, and then check the content of the relevant column. What we obtain are dates written with the help of hyphens instead of forward slashes, as it was in the case before. In addition, though, as you can see on row 5, instead of referring to the 7th month of the year, which is July, the given date refers to the 10th month, which is October. Pretty strange, considering that all neighboring dates refer to the month of July, right? And that's not the only occasion of such an error. As you scroll down, you will find similar inconsistencies. As a consequence, this is a great moment to show you why having checkpoints is so important. Now, we will not need to go back to the raw CSV data we imported more than 50 steps earlier. On the contrary, we can just go back a little, right to the nearest checkpoint, precisely to the moment of the creation of df-reason-mod, and we'll rerun the same code cell. Thus, we will return the state of df-reason-mod as it was at the beginning of this lecture, essentially forgetting all date-related pre-processing we just performed. And we will be able to start over. Then I can scroll down to the cell whose code will convert the strings from the date column into timestamps correctly. As already mentioned, doing the latter is impossible without the help of the format parameter. For convenience, I will double-click on the cell above to hide the erroneous date format we retrieved before going back to our checkpoint. Okay, so to the format parameter, we will need to assign a string value designating the structure of the current dates. It is important to remember that this parameter allows you to take control over how Python will read the current dates, so that it can accurately understand which numbers refer to days, months, years, hours, minutes, or seconds. Therefore, the string will not designate the format of the timestamps you are about to create. It's important to remember that, as it can save you time and prevent mistakes in the future. Great! Now, let's get back to coding, abiding by the following syntax when writing the string in question. We are required to attach a percentage sign plus some of the letters D, M, Y, H, M, and S, standing for day, month, year, hour, minute, and second respectively. We are supposed to stick these characters to each other without using any commas or spaces in between. In our case, we see the dates have been written in the following way: day, month, year. Hence, after comma format equals, within quotes, we must write %D / %M / %Y. Please keep in mind that Y must be a capital letter for sure. D lowercase, while M can be either capital or small letter. The convention, though, is to use lowercase letter for month and a capital letter for minute, so we will use a small letter here. Execute this cell to implement the conversion into timestamp, and run the next cell to check the new content of the date column. All dates have been converted properly, this time written in another way though. What we see is the standard timestamp format: year, month, day, all hyphenated. Great! To conclude this lecture, please consider using the type function to make sure the entire column remains a series object. Although it is composed of timestamp values, not strings. Finally, if you want to check the new data type by using even less letters in your code, you could apply the .info method to the df data frame, thus seeing that you now have 64-bit datetime values in the date column. And yes, for simplicity, please allow us to call the dfReasonMod object df, as it is clear we will be referring to our current main data frame anyway. Having converted the content of this column, let's move on to extracting its month value and day of the week. Then, we will use two different programmatic approaches for storing the obtained information as new columns in df. Thank you for watching.